Okay. Yes, Krish, you can do the
So done, sir.
courtesy. Okay.
Started.
Okay, fine. The question being, a sphere of mass and radius r, a sphere of mass and radius r is rotated with angular speed omega. A sphere of mass and radius r is rotated with angular speed omega. It is dropped on a plank. It is dropped on a plank which is kept on a smooth surface. It is dropped on a plank which is kept on smooth surface. If the coefficient of restitution, now this is new, if the coefficient of restitution, abbreviated by simple E, is equal to half, if the coefficient of restitution is equal to half, find will the sphere, will the sphere slip over the plank, find will the sphere slip over the plank before it leaves it, or it will slip, or it will slip after of losing the contact, or it will slip after of losing the contact. Second case is slightly hypothetical. By that what I mean, that it is to slip, but it will slip only after losing contact. That means before it slipped, before it leaves, slipping is arrested. Clear, dear?
Yes,
Before
yes, sir.
it leaves, there was no slipping. There can be two cases associated with it. Let me enunciate them to you. Let me first make you privy to what do I mean by coefficient of restitution. Coefficient of restitution for now is just a symbol to you, and that in this case is half. What it is to translate to is if v is the speed with which sphere will hit the plank, then v by 2 is with which it will leave, limited to it. Clear, dear?
Yes,
Yes,
sir.
sir.
What did I say? What did I say to us? What we are to treat coefficient of restitution as our knowledge being very suboptimal. We are not known to it. We are not known to it in detail. So what I'm asking you to keep up to, just keep up to there being a sphere which you have dropped, and as it meets plank which is kept on smooth surface, plank is kept on smooth surface, there's mu between plank and sphere, mu between plank and earth is zero. Is it okay?
Yes, sir.
So as the sphere makes a contact, when it is making a contact with plank, it is moving down with velocity v. Find here.
Yes,
Yes.
sir.
Yes, sir.
As it leaves, it leaves with velocity v by 2. Is it okay? It
Yes.
is moving downward with velocity v. When it breaks off the plank, it is moving upwards with velocity v by 2. Please don't read beyond it. By that, what I mean to say is, I have not commented, I have reserved my comment on whether the sphere will move in X direction or not. Am I clear? That information you are to get on your own through uses of your faculties. I am just letting you know that what does E transpire to? E translates to if V is in the vertically downward direction before collision, then V by 2 will be in vertically upward direction after collision. Find ya?
Yes, sir.
So in a
So
way,
it's
what
like a
I'm
ratio.
trying to suggest is E relates to only the vertical component. Fine, Krish?
Yes, sir.
What I'm trying to suggest, Adesh and Vedant, that E relates only to the vertical components. It has got no trucks with horizontal component. Having said that, I cannot have a blanket perception of horizontal component will be zero. What did I say? It relates to. It is in no way to comment on horizontal component. It does not mean that horizontal component is ought to be zero. Find ya?
Yes, sir.
Okay. Certainly there can be horizontal component. By the way, the case that is at your disposal as of now will certainly have horizontal component after of collision. It is but to have horizontal component after of collision. But E doesn't relate to horizontal. E relates only to the vertical component. By vertical, what I mean, if I am to make it a generic statement, I mean perpendicular to common surface. Find ya?
Yes, sir.
Yes, sir.
Whenever two bodies are to collide, there will be a common surface. Find ya?
Yes, sir.
Perpendicular to that common surface is what we take component of velocity in order to find coefficient of restitution. Find it. Is it fine to all of you? As I've told you already, I'll be going into center of mass. These are the portions of center of mass, which ironically, as you know, is not a topic at all. But we know the import of it. So I am to take center of mass with you. But for now, limit your understanding against coefficient of restitution, and what it is to be limited to, that V is downward before collision and V by 2 will be upward after collision. Find ya?
Yes, sir.
Yes.
Okay. And if that is what we are to keep to, think about this question back your place. A very important question to the extent it can feature in Olympiad. The question being, think about the question, please. I have already given you some hint on this question when we were solving some other question the other day. I told you that there can be a case that sphere has been made to roll and sphere hits the plank and without slipping on the plank leaves it. Idea?
Yes, sir.
Without slipping on the plank, it leaves it. One case, I'll make it all the more understandable to you. Let's say this was also zero. Let us say this was also zero for the time being. Are you getting it?
Yes, sir.
And you have dropped sphere from where? From some height. Correct? Here you have dropped it from where? From some height you have dropped it. Fine. Initially V was zero. Now if it drops by height h, then you very well know when it hits the plank, it will have a speed V equal to under root of 2gh. Agreed here?
Yes, sir.
Yes, sir.
V is equal to under root of 2gh. This will be the speed with which it will hitting the plank. Right here?
Yes, sir.
Okay. Now, as it has got coefficient of restitution, it goes without saying that it should leave the plank. Fine.
Yes, sir.
So what will happen? It will hit the plank and in no time will leave the plank. When it leaves the plank, it will be moving with what velocity in the upward direction or component of velocity in the upward direction? V by 2, correct?
Yeah.
Yes, sir.
Correct?
Yes, sir.
And to your surprise over here, plank will not move. The surprise in this case, plank will not move. Tell me, why did I say so? Why did I say plank will not move? Because plank to move requires a force in horizontal direction, correct?
Yes, sir.
Yes, sir.
This exercise of yours, this event that we are in, is not to get plank any force in horizontal direction. Think about it.
Yes, sir. Yes, sir.
So
Yeah.
what will happen? The sphere will hit, and as it was rotating with angular speed omega, it will keep on rotating with the same angular speed omega. Nothing will happen to omega either. Tell me, why did I tell you that? Why did I say nothing will happen to omega? Because again, omega to change, you require torque about center of mass. Say me yes or no?
Yes, sir. Yeah.
Yes,
Yeah.
sir.
And normal energy are to pass through center of mass. Correct, yeah?
Yes, sir.
Yes.
So which force would have produced any change in omega for a sphere?
Friction.
Only force of friction, correct?
Friction. Yes, sir.
Which is
Yes, sir.
absent. Find here.
Yes,
Yes,
sir.
sir.
Yes.
Taken mu equal to 0, which is absent. So what happened to omega? Omega will remain the same. Fine.
Yes, sir.
Yes, sir.
So body will slip on the plank and move upwards. Getting it here?
Yes,
Yes,
sir.
So what
sir.
happens
Yes,
to
sir.
the sphere? The sphere will slip. It is to depart. Given that it is to part from plank. Say me yes or no?
Yes, sir.
It
Yes,
is
sir.
part from plank. It will part from plank. Say me yes or no? Will it part with plank or not? Will the
Sir.
sphere part with plank or not? Tell me yes or no.
It will.
It
Yes,
Yes,
will
sir.
part
Well,
with plank. And if it will part with plank, then it can part with plank either rubbing the plank or without rubbing the plank. Getting it here?
Yes, sir.
yes,
So
sir.
in this case, if mu is 0, if at both the places mu being 0, then what we can say, this mu is what we relate to more as of now. If this mu is 0, then what we will say? We will say that it will part with plank and will rub the plank. Correct, yeah?
Yes.
Because
Yes,
omega
sir.
doesn't change, omega remains the same. So what will happen? It will part, and at the same time, when it is parting or before parting, it will slip on plank. Correct?
Yes, sir.
Yes, Yes, sir. sir.
Okay, in the second case, what can happen? In the second case, the possibility being if there is sufficient mu, if there is sufficient mu between what? Between plank
Plank
and
and
sphere
sphere.
to arrest that slipping. Are you getting it?
Yes,
Yes,
sir.
sir. Yes, sir.
Parting being inevitable, it is to part with. So parting being inevitable, it will part, but can part first with slipping, second without slipping. Getting it?
Yes, sir.
Yes, sir.
Yes, sir.
My question being on, if mu is given to you, some value of mu is given to you, or if the author asks, what should be mu? It can be rephrased. Rather getting you mu, they can ask you what should be mu for a sphere not to slip over plank. Correct, yeah?
Yeah.
sir.
Yes,
Yes,
sir.
sir.
It can be articulated in whichever way the author deems fit. Please remember, this is a question which you should try solve, and to get you some hint on it from my end, some input on it, I solve for you a question of similar nature. I said similar. I didn't say that the question will be in toto. Certainly, I'm not to get you in toto. So I'm just letting you know a question of similar nature, a question which is akin to it. And the question being, there is V given to you, initial 0, and when it hits the ground, then V is under root of 2GH, let's say. So this is being dropped from height h. It was given certain omega as well, and it being dropped to hit ground. Find here.
Yes, sir.
Yes, sir.
After of hitting, it will move with what speed? It will move with a speed v by 2 half. That means E is being camouflaged in the statement. E is equal to 1. Coefficient of, sorry, 1 by 2. Coefficient of restitution is half. Correct, yeah?
Yes, sir.
Yes,
Okay,
sir.
so that is camouflaged in the language of question. Anyway, what does the author ask over here? The author did ask you on what will be the value of Vx and Vy after collision. What will be the value of Vx and Vy after collision? So tell me about Vy, you know everything will be V by 2, correct?
Yes, sir.
Yeah, yes,
Vy
sir.
is now given by the author, and Vy he has said to be kept to V by 2. But he has asked you on Vx. Now how will you get Vx? Which force can provide X component inkling to the sphere? Tell me dear. Which force can give it an inkling on affiliation in X direction? If it is getting an affiliation in X direction, that is to be attributed to a force. Which force can it be? Tell me, please.
The
It has
friction.
hit ground.
The
And it has
friction.
hit ground spinning. Are you getting it? It has hit ground and it has hit ground spinning. So this is also in a way a cricket bowling, which we call top spin. A cricket bowling, which we call top spin. You have thrown a ball, and you have thrown a ball rotating it the way that it has been shown on board. It is rotated clockwise. Correct, yeah?
Yes, sir.
And
Yes.
by your experience, if you will toss a ball rotating it clockwise, after of hitting ground, how will it move? Let me ask you a practical question, anecdotal evidence. Anecdotal evidence. If you have not done, please do it right away. If you have not yet practiced, then please do it right away. Toss a ball, rotate it clockwise. Rotate it clockwise and toss it. Find ya? You can do that, correct ya?
Yes, sir.
Yes, sir.
Yes, sir.
Then see when it hits ground. Then see when it hits ground. Take the anecdotal evidence. When it hits ground, what will happen to the ball? Will it go vertically upward or will it have an affiliation to move away from you?
It's away from us.
Move away from
They'll
us.
move away from us. No doubt about it. No doubt about that it is to leave ground. Correct, yeah? Say yes or no?
Yes, sir. Yes,
So it will start with ground. So it is to move upwards. But at the same time, it will have an affiliation to move away from you. Say yes or no?
Yes, sir.
Yes, sir.
Let me ask you all. If you drop the same ball on a smooth surface, what do you expect you will get? Though smooth surface, you will never be able to find anywhere. But if you are dropping on a polished surface, if you are dropping it on a polished surface, and then it's being asked, will it have the same affiliation to go away from you? What will you be answering on this question?
Sir, no, because
So
there's
it will
no
bounce up and down on its position.
It will not have. See, bouncing depends on coefficient of restitution. So I will not comment on bouncing. Bouncing may remain the same. That is, it will leave ground with V by 2, and that is to remain undeterred. Is it okay? That will be unscathed. That is not to change. Idea, because I'm not relating it to Y direction motion. I'm relating it to X direction motion. Getting it?
It'll be at its position and only. It won't move forward or backward.
Okay, yeah. Now, if it is polished, then you're not talking of mu being 0. Then I'll say, Adesh, owing to certain value of mu, which is not 0, it will have some affiliation, though reduced to a wind power, yet it will have some affiliation to move away from you. Correct, yeah?
Yes, sir.
Yes,
If it is frictionless, then what you said, Adesh, is absolutely correct. It will keep on rotating. It will not move away from you. Yes, it will move vertically upwards. Correct?
Yes, sir.
Yes.
Yes, sir.
Okay, so that being the case, and this is certainly not the case for the question at our disposal. Tell me here what is to happen. The question in deliberation certainly is not that case. Why? The question in deliberation has got an inkling in X direction. I'm asking you, this X direction inkling you are to attribute to which force? Tell me, dear.
Friction.
Force of friction. Why? Because it hits the ground spinning, correct?
Yes, sir.
Yeah.
Right,
Hits
sir.
the ground spinning. So what happened to this point? This point will rub the ground. In which direction? You know that very well. So what will ground do? Ground will try to reduce omega. Say me yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Ground will try to reduce omega. Ground will apply a force of friction in which direction? In this direction, FFR.
Forward.
Correct? Why did I write FFR? I'm writing FFR because I don't know whether it is to slip or not. Are you getting it? So I'm playing safe over here.
Okay, yes, sir.
Yes, sir. Yes, sir.
If to slip, I'll have to write FK. If it is not to slip, I'll be going with FS. Correct?
Yes, sir. Yes, sir.
So I have taken both in a short. I have written FFR. I don't know whether it is to slip or not. But if the author says that it doesn't slip, if the author says, mind you, the caveat, okay, operational word, author. If the author says that there was no slipping, fine.
Yes, sir.
Yes, sir.
Then what we can say? Then we can say, yes, we do qualify writing FFR, FS.
Yes, sir.
And then author did ask, what will be Vx? In this question, author has told you that there is no slipping. Find ya?
Okay, yes, sir.
Yes,
Then
sir.
has asked, what will be Vx? Fine?
Yes, sir.
Yes, sir.
Okay. Now tell me, as per impulse, which you know, impulse I have taught you. Okay, again it is a part of center of mass or conservation of momentum as we call, initials being same COM, center of mass or conservation of momentum. What we have read impulse is nothing but force multiplied with time of operation, correct?
Yes, sir.
Force multiplied with time of operation, and also impulse is nothing but change in momentum, correct?
Yes,
Yes,
sir.
sir.
Which momentum?
Yes, sir.
Linear momentum,
Linear
correct? Yeah.
momentum.
Because
Yes,
I'm
sir.
talking of
Yes.
linear impulse, I'm not talking of angular impulse, right?
Yes, sir.
Yes, sir.
Which momentum? Linear momentum. Let me then ask you, if it is so, how many forces are acting on the sphere given? On the sphere given, there are normal, the other energy, and third force of friction. So there are three forces acting. Agreed, yeah?
Yes, sir.
Yes, sir.
Three forces are acting. There are three forces acting: normal, mg, and force of friction, static force of friction. Now, remember and keep it to yourself. mg can never be impulsive. Is it okay? mg can never be impulsive. Why mg can never be impulsive? Because mg is a force which cannot shoot to infinitely high value in whatever time span you give to it. Any force which is constant cannot change its value. So there cannot be Dirac delta, as we call Dirac delta, shooting very high. So there cannot be an impromptu shot to the value, correct, dear?
Yes, sir.
Yes, sir.
Yes, sir.
So the forces which are constant can never be in any way linked with the epithet impulse. Getting it, dear? You
Yes,
cannot relate them to the epithet impulse. Impulse means something which you cannot comment on, correct? Yeah, the person is impulsive, right? So he
Yes,
can
sir.
act
Yes.
weird, right? Yeah, are you getting it?
Yes,
Yeah.
He
sir.
will not respond, he will react, correct?
Yes, sir.
But if
Yes,
you're
sir.
talking of a sane person, then he will respond instead of reacting. Say me yes or no.
Yes, sir.
Yes, sir.
Yes,
So
sir.
sane persons are non-impulsive in nature, correct? Yeah.
Yes, sir.
Yes, sir.
Okay, so look at this scenario out here. mg being a constant force, so mg can never be impulsive, remember. mg is not impulsive. mg cannot change momentum in a small time. The other way of understanding the same concept is mg cannot change momentum. mg cannot bring about considerable change in momentum in insignificant time. Are you getting it?
Yes, sir.
So no
Yes, sir.
significant change in momentum if mg acts for insignificant time. But same you cannot say for normal. Think of a ball coming to you. You hit the ball by bat. What you do to its moment? What you
Change
do
it.
to the ball's momentum? You change the
Input
ball
it.
momentum in no time.
Yes,
Correct,
sir.
dear? You
Yes, sir.
change the momentum of ball in no time. Correct, dear?
Yes, sir.
Yes,
Yes,
sir.
sir.
What did you apply on ball? You have applied on ball impulse. Correct, yeah?
Yes,
Yes, sir.
sir.
Yes, sir.
And which element of cricket is applying impulse on ball? Not you, the bat. Correct?
Yes, sir.
Yeah.
Yes, sir.
Okay, got it, yeah?
Yes,
You're
Yes, sir.
sir.
handling
Yes, sir.
it, you're maneuvering it, but it is being in contact with bat, so bat is applying force on ball. Correct, yeah?
Yes,
Yes,
sir.
sir.
Yes,
And
sir.
force can be given the attribute that force qualifies to be called impulsive force. Why? Because it has got the power to change momentum in no time. Correct?
Yes, sir.
Yes, sir.
Yes,
The
sir.
same you cannot attribute to mg. Find here. So remember forever now and keep it to yourself. mg can never be impulsive. Fine?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, good enough.
So
So,
can
which
friction be
force?
impulsive?
Yeah. Yes, Krish.
Can friction be impulsive?
Yeah, friction can very well be impulsive, Krish. If you are talking of friction which relates to normal, then you can find that impulse. But if you are
Yeah.
talking of friction which doesn't relate to normal, then you cannot find the value of impulse. Is it
Okay.
okay? But if
Yes.
I'm relating to friction which is either Fk or Fs maximum. Got it, dear?
Yes, sir.
Either Fk or Fs maximum. Then I can relate that friction to normal. And that is what I am making you learn over here. How will you relate friction to normal? It is a very simple understanding, by the way. Please see for yourself. Tell me first, which forces are according to you or can according to you be impulsive? You will say one is normal and the other is force of friction, correct?
Yes,
The
sir.
other is force
Yes,
of friction, correct, yeah?
Yes, sir.
It can be anything. It can be Fs, it can be Fk, whatever it may be, or Fs maximum. It can be anything. But friction will be impulsive, and that is the entire which I am into for this question to make an exhibition for. And that is what you will learn from here. Normal is the only force to change vertical component. Can we say?
Yes, sir.
yes, sir.
Normal is the
Yes,
only force which can bring about change in vertical component of momentum. So yes or no?
Yes, sir.
Yes, sir.
And normal into dt, if I multiply or go for the summation, then what we are to say, if I'm not going for summation, then I'm talking of small change. If I'm going for summation, then I'm talking of before event, after event. Is it okay?
Yes, sir.
Yes, sir.
Yes,
What
sir.
is event over here? Collision. Correct, yeah?
Yeah.
Yes,
Yes,
sir.
sir.
So just before event, just after event, you know that only normal can be ascribed the change in momentum to. So let me ascribe the change in momentum to normal and ask you, what is final momentum? You will say m into v by 2, right?
Yeah.
Yes,
Then
sir.
I'll ask you, in which direction? You will say upwards, correct?
Yes, sir.
Yeah.
Yes, sir.
You need to be very careful. Impulse is a vector quantity and normal into dt when you write, it is in which direction? You are taking it in the upward direction as normal is being shown in the upward direction, correct?
Yes,
Yes,
sir.
sir.
So upward direction for us is positive, correct?
Yeah. Yes, sir.
Yes, sir.
I have taken, you can take downward as well. I have taken n into dt and n is upward. So I am going with upward direction as positive. Find yeah.
Yes, sir.
Yes, sir.
Okay. So final momentum m into v2 minus. Now initial momentum I have to write. What shall I write? Initial momentum of sphere was mv, correct?
Yes, sir.
So
Yes,
can
sir.
I write straight mv over here? Can I write mv over here?
Yes,
Can
sir.
I write mv over here? Yes or no? Can I
Yes.
write
Yeah.
mv over here?
Yes,
Just
Yes,
now,
sir.
Yes,
answer
sir.
to the question which I am asking you now. I gave an answer to this question few seconds ago, and now I qualify asking this question. Can I write MV there? Can I write MV there? Say
Yes,
yes or no.
sir.
Yes,
No, you
sir.
Yes,
cannot.
sir.
I told you I have taken upward direction as positive. Correct? Correct.
Yes,
I
sir.
told you
Yes,
I have
sir.
taken upward direction as positive. Yes or no?
So
Yes,
minus
sir.
of minus MV.
So, what shall I write? Tell me the body was moving down before of collision, correct? Yeah. And moving down with speed v, correct?
Yes.
Yes, sir.
Yes, sir.
What should I do? Tell me. Improvise.
So minus MV.
The minus of
Minus
MV.
of MV. So there will be a minus sign over here, right, Adesh? Right, Vedant?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Is there, Adesh? You're saying something?
Yes, sir. Understood. Understood.
Okay. So what do we get from here? 3mv by 2. N into dt is what to us to read? 3mv by 2. Fine. So this is
Yes,
an
sir.
this is impulse due to normal, right? This is impulse due
Yes,
to
sir.
normal. And if this is impulse due to normal, and I wish to calculate what will be change in x direction, then what I deem calculate is what will be Fs dt. Think about it. If I get a mean to calculate Fs dt, then I get change in momentum along x direction. Agreed?
Yes, sir.
This
Yes,
is
sir.
fair. Momentum in y direction you can attribute to normal, and momentum change in x direction you can attribute to which force? Tell me, dear.
The friction.
There's only
The
one force
friction.
acting in x direction, so it is all the more easier for us to access. It is all the more easier for us to take a note of there being only one force to which we can attribute change in momentum along x direction, right?
Yes, sir.
Yes, sir.
And what I'm writing for it, I'm writing Fs into dt, right? What is Fs into dt? Fs into dt is impulse. In which direction?
X direction.
X
In x
direction.
direction. And about impulse, impulse is nothing but change in momentum, correct?
Yes, sir.
Yes, sir.
Momentum in which direction, all of you? Change in momentum in which direction, all of you? X direction.
X direction.
Know what it is now, so I'm writing mvx, but initial is known to us 0, correct?
Yes.
Yes, sir.
I don't know what it is now, what is final, what is after of event, what is after of collision is not known to me, but I'm certainly known to what it was before collision. Yes or no? Before collision,
Yes.
sphere was moving only in y direction, it was not moving in x direction. Got it, dear?
Yes, sir.
How do we find Vx? Sir?
Yes, dear?
How do we find Vx?
Yeah, I'm coming to that, dear. I'm coming to, just hold your horses, I'm coming to it. M into Vx minus 0, correct, dear?
Yes, sir.
This is what we got, m into Vx minus 0. Fine. Now, our aim was to calculate Vx. Our aim was to calculate Vx. And Vx, as Krish had confusion, of course, we will not be able to calculate Vs. Reason? Why will I not be able to calculate Vx? I will not be able to calculate Vx in want of Fs. I will not be able to calculate Vx in want of Fs. But if the author gets me the liberty, if the author gets me the liberty of working this question out on limiting friction scale, getting it?
Then okay. Yes, sir.
If the author gets me the liberty, if I can exercise my liberties on solving this question, or if the author is positioning this question to limiting equilibrium state, by that what I mean?
Sir,
By that what I mean?
Fs
I can change. By that what I mean? We have the right to change it to Fs maximum. Getting it here?
Yes, sir.
Yes,
We
sir.
have the right, then we can exercise very easily, taking some liberties on what author must have positioned this question as. Otherwise, it will be difficult for us to get to the end of the question. Otherwise, I'll have to rephrase this question and ask you what will be value of mu, which is what I'm not asking. I'm keeping to the language which I made you write. So here, the author will have to qualify this question by letting you know, or there should be a supplement statement, and that being work it out under limiting equilibrium state. Am I clear?
Yes, sir.
Yes, sir.
And if that's the case, then what can I write over here is mu into n into dt. Say me yes or no.
Yes, sir.
Because Fs maximum can be marked mu into normal, right here?
Yes, sir.
Yes,
Can
sir.
we replace NDT from the first equation here?
Yes, dear, yes, Krish, you are asking something. Please come again.
Can we replace integration of NDT from this equation here?
Now we can do. Or if the author says that it roughs the ground, getting it, dear?
Yes.
sir.
Yes,
If
sir.
the author says that it roughs the ground, even then you know very well you can use mu into normal, correct?
Yes, sir.
Okay, and generally author, particularly Ayurveda, will get you the same value of mu for mu k and mu s, so that they can do. Find yeah, they will not let you know what it is because they want to keep from you as they want to test your intellect. Correct? So they will get you just mu. Coefficient of resistance is mu. Friction is mu. Correct, yeah?
Yes,
Yes.
sir.
Yes, sir.
So if it is given to you in drafts, what you can do, you can again go with the same equation. Once you are through, you know what you are left with. Mu will be out and dt will be changed by 3mv by 2. Agreed?
Yes, sir.
Yes, sir.
T from here will be changed by 3mv by 2. That is what I have done for ndt integration, and is equal to what to us? M into Vx. We get Vx from here, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Vx with which sphere which you tossed up, rotated and tossed it up. This is the speed with which it will move in x direction. Find yeah?
Yes, sir.
Yes,
Of
sir.
course, you can see for yourself, it depends on mu. If mu is 0, Vx will be 0, right? Yeah?
Yes, sir.
Yes, sir.
Substantiated it mathematically as well, correct?
Yes, sir.
Yes, sir.
Great. Now, the question which I have gotten you, please be pensive about it. Please keep brooding on it. I'm not asking you for a solution. Of course, that is not the purpose. Getting it? But
Sir,
keep on brooding. Never lose sight of it. Fine?
yes, sir.
Yes, sir.
Okay.
Sir,
Yes,
you
Chris.
helped us find Vx in this. Sir, you helped us find Vx in the same question, no, sir?
Yeah, but that is not the same, Krish. I told you.
Okay,
It
yeah.
is not the same in toto. Why? Because there you are dropping on a plant which can itself move.
Okay. Here you're dropping on ground.
Here it was dropped on ground. Ground cannot move. Correct? Yeah.
Yes,
Base
sir.
cannot shift here. Their base itself can shift and will shift because it is kept on smooth surface.
Yes, sir.
Right? Think about
Yeah.
it. Good
Yes, sir.
question in waiting for Olympiad examination. Okay, let's get started with fluids now. Fine?
Yes, sir.
Yes,
Having
sir.
said that, having said that, please never live in illusion that I have taken an off from the topic that we are through, be it kinematics, be it laws of motion, be it work by energy, or the current one, rotational mechanics. All the 4 chapters to me will be said done only when, and I emphasize, only when you have seen each and every question of Ayurveda. Am I clear?
Yes, sir.
Yes, sir.
So please, if you have not, and if you are having time, indulge. It is not that you are through rotational mechanics XYZ question, so you are through the topic. It is not at all the case. And whatever you are to do right this year. This is for, of course, Adesh and Vedant. And for Krish, I need not tell this. Right,
Yes, sir.
Krish?
This is the
Okay,
only
because
year.
you don't have an option. So I need
Yes,
not
sir.
tell you, I'm not addressing you. I'm addressing Adesh and Vedant. Please be off this perception that you do have another year. You don't. Am I
Yes,
clear?
sir.
And I
Yes.
will not
Yes,
let
sir.
you rest easy. Let be sure about it. I'll not let you rest easy. So I'm to make you work, solve Ayurveda, and if you are not solving by persuasion, I'll have to use coercion because I'll be left with no option then. Correct, yeah?
Yes, sir.
Okay,
Yes,
so
sir.
please be volunteering it, start solving it so that you don't eat up my time. Else, what will
Yes, sir.
happen?
I am.
I'll throw hints to you and I'll wait for the time till you get me some substantial advancement. I'm not asking you for an answer, but I want some from your end substantial advancement on questions. Unless and until you get me, I'll
Yes.
not move further. Okay,
Yes, sir.
so
Yes.
Yes,
spare
sir.
me time by indulging now. Spare me time by indulging now so that we can take additional questions. Else, you
Yes,
will
sir.
keep yourself from additional questions. Getting it, dear?
Yes. Yes, sir.
Okay. So let us get started with the topic for the day. Fluid mechanics. Write down fluids, only fluids. Start with only fluids because
Sir,
fluids will be later divided in static and dynamics. Correct, yeah?
so does mechanics hold any importance here in fluids? Like,
Fluid mechanics, when you say you are addressing in one shot statics and dynamics. Correct, yeah?
yes, sir.
Because you are talking of mechanism, correct?
Yes, sir.
So when you say fluid mechanics, in one shot you have addressed case statics and dynamics. I'm not to take it that way. I'll be taking in piecemeal. So I'm compartmentalizing it. First part being fluid statics. Is it okay?
Yes, sir.
Yes, sir.
Yes,
When
sir.
I say fluid statics, what I mean by it, I'll come to it, but make me understand what you have for fluid to explain to me. What is
Sir,
your meaning of this word fluid? I want an explanation. Explain to me the word fluids. What comes to you and from where it stems? Tell me, dear.
Sir, anything which
so
can flow.
fluid can be like a liquid or a gas, something that does not have a fixed
Yes, I'll
volume
take that.
shape.
I'll take that. You are absolutely correct. A liquid or gas. So are you, Krish. Anything which can flow. Right, dear?
Yes,
Anything
sir.
which
Yes.
can flow. As we know, liquid and gas, they are only which can. Therefore, we are associating it with liquid and gas. But what amorphously we can say? We can say amorphously, anything which can flow is given the epithet fluids. Clear, dear?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
we began with fluid question. Now I'm to add to our beginning a premise. And what that premise? The premise which I have to add right at the top of discussion fluid is fluids which we are to forever adhere to pronounce will be read against two properties exhibition. First is incompressible. Second is non-viscous. So unless stated otherwise, getting it dear? Unless stated otherwise, we are to carry this premise. So what the premise we begin our study of fluids with? Unless stated otherwise, we will take fluids to be A, incompressible, B, non-viscous. Am I clear?
Okay, sir.
Yes, sir.
Yes, sir.
Incompressible and non-viscous. I'll explain it to you what I mean by it. Incompressible is pretty easy to understand. It goes by whatever we have in English and understanding for the word incompressible. It is not a technical word. Correct, yeah? Non-viscous
Yes, sir.
Yes.
technical word. I'll come to the explanation of it. But incompressible, whatever we have in English, it is to be over here taken as it is, which is something which is difficult to compress. Correct, yeah? Something which we will not be able to compress. Correct?
Yeah,
Yes,
yes,
sir.
sir.
So if we are hell-bent on getting it a flavor of science, if we are at all hell-bent on flavorizing it, getting a flavor of science, then what we can say, the any substance or any object or whatever you take, if the density has got no trucks with pressure, if density has got no trucks with pressure, clear dear?
Yes, sir.
Yes, sir.
The
Then
density
that
has got no.
object, that element, that substance is called incompressible. Clear dear?
Yeah, yes, sir.
Yes, sir.
That substance will be called incompressible, subject to absolute. I've told you already that if you want to get the flavor, we can say if pressure is not to affect density, or if density is immune to pressure, is alienated of pressure. Clear, dear?
Yes,
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 sir.
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 So what we are to call those substance? We are to call those substance incompressible. Am I clear, class?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, so this is about our understanding of the word incompressible and what we mean by viscous, non-viscous. Now, this is important to us. What do we mean by viscous and non-viscous? You all have experienced it. You all have a reason to call, let's say, sauce more viscous than water owing to the rate of flow of sauce and water of a bottle, correct?
Yes,
Yes,
sir.
sir.
Okay, so you know and you are privy to, experimentally privy to the very property viscosity. But today we will learn about why do we have this property associated with liquids. why don't we see the same associated with the other fluid, which is gas? Clear, dear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Because both are fluids. You have your admission being gas is fluid, so is liquid, correct?
Yeah, yes,
But
sir.
we associate
No.
flow, but we associate flow or viscosity more with liquid than with gas, correct?
Yes,
Yes.
sir.
Yes,
Why
sir.
this preferential treatment? Why is this favorism? Why this nepotism? Reason being, when liquid flow, any liquid you take, when liquid flows or when liquids flow, then they flow in bulk. When liquids flow, then they flow in bulk. By that, what I mean, if I cite an example of river, if I cite an example of river, then we are of the impression that river is flowing at a particular rate which relates to every layer of river. That means if we are of the opinion that the top layer is moving with the same speed as that of the river layer touching the bed of river, getting it?
Yes, sir.
Yes,
Of
sir.
the impression that top layer of river is moving with the same speed as that of the layer touching the bed of river, then we are relating river to a non-viscous liquid. Clear, dear?
Okay, yes, sir.
Yes, sir.
Yes, sir.
Then we are relating river to a non-viscous liquid. Then we are saying water is non-viscous. Why? Because I have attributed only one velocity to the bulk water. Right there?
Yes,
The
sir.
Yes,
bulk
sir.
entire of water, by entire what I mean, to layer which is at the top, which I am privy to, which is apparent to us, and layer which is at the bottom, layer which is at the bottom.